Can hang out over here. All right, so let's get started. First of all, we're going to start with a little sizzle reel, okay? So this is HTTP. Oh, maybe we don't have internet. No sizzle reel for you guys. Okay, we'll get to the sizzle reel later. The agenda today is really simple. This is a short 20-minute talk. We're going to be talking about Play 2.6 and their recently added support for HTTP2. We're going to be talking about HTTP2 in depth, the RFC 7540, and some of the features that it delivers for us as web application engineers. And then we'll just be discussing some of the use cases as it relates to us. So this is a talk targeted at intermediate Scala users. If you're an advanced Scala user, or if you're extremely knowledgeable about HTTP2, just bear with me. It's not a very long talk, but I'm hoping that you're going to be able to walk away from this session at least understanding that this is an offering that has arrived in our tech stack if you're using Play, and it's something that you might be able to take advantage of, or at least have a good understanding of what it does. So let me just introduce myself real quick. My name is David Waugh. I'm an application developer. I work at a company called ACL in Vancouver, and allegedly we're engineering the Salesforce of GRC, which is the governance, risk, and compliance space, AWS, Docker, Scala, GraphQL, some Ruby, and JavaScript and React on the front end. So you can get me at these two links here, and I'm going to put those up at the end of this deck so you can capture them then if you want. This is what our product looks like, and I wanted to show you this because it should be pretty clear to you guys that there's a bunch of data getting served on this page. It's not going to be 2 or 3 or 5 charts. It could potentially be 100 charts that are being loaded for our end user. We could be seeing a 15-second page load on this guy, which is totally not acceptable. So we have engineering problems, and if you saw the Ruby icon on the previous deck, you can probably understand that we're deconstructing monoliths. That's what we're doing every day when we show up to work. Vancouver is really beautiful. If you like it out, you should come and chat with me. Lots of hiring opportunities there. So let's talk about Play. Play 2.6 is powered by Akka HTTP. Akka HTTP uses reactive streams under the hood, and it supports HTTP2 now, which is great. So we use Play as the web framework at ACL when we are serving high throughput data. When we aren't serving a anemic model, some simple REST API, but rather we're doing really complicated stuff. Typically it's when we're using GraphQL or we need a lot of concurrency. So let's look at what HTTP2 really looks like in the wild. So this is a modification of the standard Play template, the extremely simple open source template that you can grab and use yourself. Play Scala starter example. What I've done is I've customized it so that it is very similar to the HTTP2 examples that you see online, and I'll show you a couple of links later. I would have showed you an actual example of it if I had the internet, but it's not important. And essentially it loads a bunch of resources onto the page, and this is an opportunity for us to see the difference between HTTP1 and HTTP2 in terms of how it performs. So HTTP1 over Play 2.6, loading 16 resources. These are images from the Rosetta space probe visiting a comet. We can see performance here, 23 milliseconds to load, and importantly, there's 128 milliseconds of other time processing this page load. If we come over to the HTTP2 version of Play, which is not based on the same template, but is rather based on the Play Scala TLS example, it's got a different performance profile. It's actually loading quicker. It's not that much quicker because this is an extremely trivial amount of resources to load. It's not a good showcase for HTTP2. It is a good showcase for Play because I was able to do it for you guys in the amount of time that I had. You can see that it's roughly 10% faster, but in the other category, a lot of stuff that was happening before is not happening anymore, which is nice. So I think this proves out that just straight away out of the box, you can get performance enhancements with HTTP2. But we're going to talk a lot about why, and we're going to talk about whether it's really beneficial to you in practice. Just got to find my mouse. Where'd my mouse go? There we go. Just a couple annotations on that demo. So if you actually want to recreate that TLS example, it's not super straightforward. found that there were some gotchas in that repository. You have to delete a bunch of miscommitted files in the scripts directory. SBT stage is required. And then it helps to launch Chrome in a mode that it does not enforce TLS, because otherwise you can get blocking errors. Not in Safari, but in Chrome. So let's take a step back from HTTP2, and let's just talk about HTTP1. It's really, really long-lived, serving us and the web for over 20 years. It's great for to-do style applications where you have a classic REST, SOAP API. You're doing CRUD. You know, that works fine. It probably wouldn't work fine if you're serving hundreds of resources on a page, but on a typical to-do app, I think you can get by just fine. So I'm not suggesting that we all have to jump and convert over to HTTP2. I'm merely suggesting that the offering arrived in our shared tech stack, which is interesting to me. And certainly when I saw that changelog, I had to start asking myself, what is HTTP2? Can I recommend it to my managers and the directors of technology at my work? You know, what does this mean? I didn't know exactly. And so I learned a little bit about it. It arrived in 2015 with RFC 7540. Critically, it allows you to multiplex multiple HTTP 1.1 connections across a single connection. So while in traditional HTTP you could potentially have 5 connections, it's configurable on the browser side how many you can have, but there's a maximum, or maybe on the server side there's a maximum. With HTTP, you can multiplex as many connections as you want across a single HTTP2 connection. You can add dynamic priority, cancelability, flow control. The compressed headers give you an enhanced speed. That's one of the reasons that it's guaranteed to be a little bit faster, provided that you don't hit any of the corner cases where it's not faster. And then critically, again, server-side push is a big piece of this technology. And I believe that at the end of this slide deck, I'll be able to persuade you that it is truly different than HTTP 1.1. It's not just about compressing headers. There's a material technology difference. It's great for progressive page load, which we're going to talk about, and infinite page scrolling, and there's a bunch of other use cases. I have a question for the audience, though, at this point. Are you guys primarily concerned with communicating with other back-end services, or do you guys think a lot about serving the front ends? Hands for front ends? Hands for back ends. All right, so it seems like there's a lot of concern about serving back-end services from back-end services. HTTP2 is still a good fit for that. There's still a lot of capabilities that it gives you that will help you with that work. This talk is more focused on the front end because we have egregious 15-second page loads in my workplace and we need to fix it. So that's one of the problems that we discuss a lot. Just a couple of diagrams to try and clarify this for you guys. So this is HTTP1. You got 3 resources there: JavaScript, HTML. You're going to have 3 connections to the server. You're going to have to establish each connection. You're going to have to download the resource. Then you're going to have to close that connection. It's not as efficient as one connection, especially if you're able to compress all the headers that you would have had to use in those 3 connections. And it's especially more efficient if you're using TLS encryption, so it's HTTPS rather than HTTP, which wasn't necessarily efficient for HTTP 1.1, but is built into the design of HTTP2. Here's another look at it. This really illustrates that it's not that transformationally different from HTTP 1.1 in that it's still in the protocol. It's merely a way of wrapping HTTP 1 requests together, grouping them, multiplexing them into a single connection. So HTTP2 sits around those traditional HTTP 1.1 connections. Might have been a get of some HTML, but more interestingly, it could have been a post of some extremely long multi-part file. It could have been an upload of a 1 gigabyte file. It could have been multiple uploads all multiplexed together. And you can take control of that stream. Let's talk about some benefits. So we did talk about multiplexing. One of the benefits is that there was a bunch of hacking going on HTTP 1. We were doing image sprites, concatenation, domain sharding. We want to step away from all of that hacking, and in fact, it's going to make us less efficient if we still try and do it with HTTP2, so we need to be careful about that. Obviously, we're looking for reduced latency, better web performance, search results, and this should bring our costs down, though that's not so much my interest. I'm more interested in the cool technology. So how do we get here? Allegedly, it started with Microsoft and their online Outlook application. So they were getting really sick of having to deal with users that were constantly reloading the page looking for their next email. This was back in the Hotmail era. I'm sure some of you remember that. What they came up with, along with Google, is the XHR request, which allows for Web 2.0 semantics, AJAX, refreshing of web pages while you're still on them. My understanding is that Google was actually the first to implement it in Gmail, but it could have been either of them. I don't know the history that well. But Google took it a lot further. They introduced this new protocol called Speedy, which was an extension of HTTP 1.1 and brought in a lot of the stuff that we're now seeing in HTTP2. It had compressed headers, it had pipelining, it had multiplexing, and I believe it had a version of server-side push. So it was really Google and Speedy that got us to HTTP2. Speedy was adopted by the industry, I don't know how broadly, and eventually it was standardized into HTTP2. Now Google has taken it a next step further, and they're working with their Quick protocol, which has not arrived in play yet, and to my knowledge is not being worked on. But it adds additional speed, and it serves a lot of Google's interests, which is very high initial page load on mobile properties. So you can read the Speedy white paper if you like, but that's kind of ancient history at this point. Is it adopted? It definitely is. 30% of websites online are using HTTP2. Google, YouTube, Wikipedia. I'm not sure if anybody cares about Yahoo anymore, Twitter. So the big guys. And this is a great graph. This shows year over year an increase of 100%. We went from 15% in September of 2017 to 30% adoption this year. And if you open up the network tab and you actually take a look at all your favorite websites, you're going to see this. This is really happening. And a lot of it is being driven by libraries and tools. So let's talk about what it actually feels like when you hit HTTP in the wild. Gmail definitely uses it. I encourage you to open up Gmail, compose a new mail, and drop 20 attachments, each of a megabyte, and then watch the network tab, and you can see those HTTP2 connections serving that. Spotify is a great example because there's a lot of resources that have to get dynamically pushed to your Spotify app. They have a lot of infinite scrolling. They have the actual streaming music itself. I believe that we're still at a point where HTTP2 is missing an important piece, which is to emulate or fully duplicate the capabilities of WebSockets. So probably there still are components of these web properties that are not being served over HTTP2 because they need that WebSocket bidirectional capability. Instagram is another great example. Infinite scroll. We have to keep pushing resources, but we really don't want to be doing long polling from the client side. So this is what Google has been coming up with, this purple pattern. Push, render, precache, and that's what we care about right here. And then lazy loading. The idea is that you push the resources needed so that you can get something up, some search bar at the very top of the page so that they can start interacting with your property, and that's the render. But then we have the opportunity to start pre-caching things. So we knew that the user was on the page, they started downloading HTML. If we, on the server side, have a manifest of resources in a relationship between that HTML file, CSS, JavaScript, we can actually start sending things to the client before they even know that they need it. They won't need that CSS until they start parsing the HTML. But we can actually send it to them ahead of time, cache it in the browser, so that cache hit speeds up the rendering of the page significantly. That's pre-caching. So that's when HTTP2 actually starts to feel really nice on the front end. So this is an example of that exactly in more explicit detail. So the browser requests HTML on HTTP1. HTML is parsed. We see the tag indicating that we need CSS. We reach out with a second request and get it. But in HTTP2, with a resource manifest, the browser requests HTML. The server says, oh, you need the CSS. You get the CSS cached. And then when you parse the HTML, you do not do a second web request because you have the CSS. It's one request versus two. That is a significant difference versus our traditional HTTP1 method of getting resources. I think it's definitely something that we need to consider moving forward, especially if you're interested in mobile properties or having extremely fast page load, or if you're interested in infinite scroll. And I think there's a lot of interesting possibilities on the back end as well. for server-to-server communication. This is my contact information. I strongly recommend everybody reaches out to me and adds me. I love to chit-chat about Scala and development, and I'm available for questions now and also on the breaks throughout the day to talk about HTTP2, developing applications that have high throughput and have super fast page load, and anything else that you're interested in, because I just am a friendly guy and I like to chat.
David now?
Yeah, go ahead.
Yeah, I have a question. So you mentioned WebSockets and HTTP2.
Mm-hmm.
What's the benefit of using HTTP2 over WebSockets?
It's like I planted you. Like, this is the best question for this talk. It's a short talk, and you really only are going to get one question, and that's the question that I wanted.
David, can you repeat the question?
Yeah, I can. So the question is there, well, I'm going to paraphrase your question because I think it's so interesting. Is there any indication as to what technology we should use, whether it be HTTP 1.1, HTTP2, or WebSockets, because they overlap, and it's not nice the way that they overlap. The answer is, I don't think there is a clear answer yet. What you can't do is use HTTP2 plus WebSockets on the same connection. You have to have two connections. I think best-of-breed web properties are doing that today. I encourage you to check out YouTube. You'll see HTTP2 plus WebSocket calls, WebSocket for their media player. I'm hoping that eventually HTTP2 will include WebSocket capabilities. It's so far no traction on that in the protocol development space. There is probably one piece of information that you can use to direct your choice, which is if you do not need bidirectional push, if you only need the server to tell you when it discovers a new resource, then HTTP2 is probably for you. So Instagram, infinite web scroll. You're never going to have to say to the server, hey, give me more content. It knows that you're just going to keep scrolling forever. It'll precache ahead of you. If it only needs to load resources as you scroll, then probably WebSocket's a better choice. Does that answer your question? Any other questions? Right there.
For like backend to backend communication
Mm-hmm.
servers, like would you prefer HTTP2 over something like gRPC or?
So I think they're similar. I think gRPC is a binary protocol with absolutely. So the question is, for server-to-server communication, is there material differences between HTTP2 and another binary protocol like gRPC? And I think that they're very similar. And I'm not sure if there's a material difference. So HTTP2 is not the same as HTTP1 in that it is not text-based. It's binary protocol. So I think that's the main benefit of gRPC already. I think gRPC uses compressed headers, if I'm not mistaken. So I think that sounds like 80% overlap. Beyond that, I don't have enough detail as to what gRPC offered. I think it is an older technology. I think this is going to be the replacement of it, if I had to give you my opinion. Any other questions? All right. Thank you so much.